Hey guys, welcome back. In our last lesson, we talked about partitions, the benefits of partitions, and how to work with partitions. In this lesson, we are going to see a couple of potential problems that you may see with partitions, especially with dynamic partitions, and of course, how to address them using buckets. In this lesson, we'll talk about what are buckets, and we'll see the differences between buckets and partitions. We'll also talk about the benefits of using buckets in Hive, and finally we'll also create bucketed tables in Hive and work with it. In our last lesson, we created a partition table named stocks underscore dynamic partition, which is partitioned by 3 columns: exchange name, year, and symbol. And we dynamically created hundreds of partitions on the table. Let's do a show partitions on the table to list all the partitions from the table. So as you can see, this table has about 362 partitions. So tell me, what do you see now? We see a lot of partitions, for just 2003, and similarly for 2002, and similarly for 2001. Let's pick a symbol from here and let's go into the directory for a specific year. Why don't we look at the directory for symbol BUB under year 2003. So let's do a HDFS listing on that specific directory. Now here is the output of the listing. Take a few seconds and tell me, what do you see now? I see a tiny file under the partition symbol BUB under year 2003. There are 2 problems here. Problem number 1, too many partitions. More symbol for a given year will end up with that many partitions. Meaning for each year, based on the number of new symbols added to the exchange that year, the number of partitions can actually vary, and it is not predictable. Problem number 2 is tiny files under the partitions. We know that Hadoop is not an ideal platform to deal with tiny files. We may argue that symbol is not the best column to partition your data by, but nevertheless, you could be facing a similar scenario in your job. So how do we address these 2 problems? The answer is buckets. Take a look at the create table statement right here for creating a table stocks underscore bucket. In this table, we are partitioning the table by exchange name and year. Then we are saying clustered by symbol into 5 buckets. What it means is that first partition the data set by exchange name and year, and once the data set is partitioned by year, store the records for the year into 5 buckets. In other words, 5 files using the symbol as your bucketing column. Let's now talk about how the records get stored into buckets. Each symbol is assigned to a bucket number using a hash function, and all the records for that symbol will be stored into the assigned bucket. So if symbol XYZ is assigned bucket number 3, all records for XYZ will be stored in bucket number 3. Let's create the table first. Let's execute the describe command on the table. And there you can see the table is partitioned with 2 columns, exchange name and year. And you can also see the bucketed column symbol, and the number of buckets is set to 5. Let's now insert record into this table. As you can see, the insert is just like any other insert. But make sure you set Hive enforce bucketing equals true. Since this insert is going to create dynamic partitions as well, let's make sure to set all the properties needed for dynamic partitions. First, the dynamic partition should be set to true. And next, I'm going to set the number of dynamic partitions allowed to 1000. And I'm going to set the number of dynamic partitions allowed per node to 500. Now let's also set enforce bucketing equals true. There you go. All the properties are now set. Let's execute this insert. You can also see the number of reduced tasks determined at compile time equals 5, which equals to the number of buckets on this table, which is also 5. The insert is now complete. As you can see, 3 partitions got created for this table. And under each partition, you will see 5 buckets. So that is why the number of files is 15. 5 buckets under each partition. Let's now go ahead and look at the partition for year 2002. And there you go. And as you can see, there are only 5 files or 5 buckets as opposed to too many tiny partitions. So this is the benefit of buckets. You will get a constant number of buckets and you will also avoid tiny files. The second benefit of buckets is during sampling. Sampling is beneficial when you don't want to query the entire dataset and you would only like to analyze a random sample. Take a look at this first select. In this select, you're doing a table sample on a table, stocks, which is not bucketed. And you're asking for bucket 3 out of 5 buckets based on the column symbol. Now, since this table is not bucketed, Hive has to randomly assign symbols into 5 buckets, and rows which belong to the third bucket will be returned. The problem with this query is that to return bucket number 3, the table sample needs to scan the entire table because the table is not bucketed. And this is time intensive. On the other hand, let's look at this select on the bucketized stocks underscore buckets table. This query is efficient than the first one as the table we are sampling is bucketized. And also the sampling is done on the bucketized column symbol. Hence this query will be more efficient than the first one. The other benefits of buckets is its efficiency during map site joins. We'll look more detail into that when we talk about optimizations. So let's summarize what we learned from this lesson. In this lesson, we understood what are buckets, we saw the difference between buckets and partitions, and we also know how to work with buckets. We saw 3 benefits of buckets in this lesson. Unlike partitions, the number of buckets is constant and solves the tiny files issue. Buckets are very efficient when sampling tables. And finally, the benefit of using bucket is during map site joins, which we'll see in more detail later. With that, let's wrap this lesson. See you in the next lesson.